Knoxville Game Design, December 2019. SDL with C, with Jacob and Levi.
Welcome everyone to Knoxville Game Design for December 2019. This is a monthly discussion of our game projects and game development topics. My name is Levi Smith. I'm in Oak Ridge, Tennessee. Looks like we have Jacob.
I think your mic's turned off.
Oh, okay. Hear you now, Jacob. Yeah, go ahead and get started for this month. Didn't have too much news, but let me go ahead and share out my screen here. So one thing I noticed is Dylan on his Twitter, he mentioned something about Peach Jam. I think this is a part of MomoCon in Atlanta. Looks like it's... actually this is in December. So yeah, maybe this is coming up in a couple of weeks. Yeah, I thought this was a part of MomoCon, but I guess this is something different. So yeah, I'm not sure if this you have to work in teams or if you can work individually. It looks like you do have to work on site on this, so I'm not sure. You have to be 18 plus, and you do have to have a $10 deposit. So yeah, it sounds pretty cool, like a good time. The only question I have about this is, like, do you bring your own? Jacob, did you have anything you wanted to talk about or show off? We showed off your Ludum Dare game a couple of months ago.
Yeah, I don't really have anything to show off that really has gone very far.
Okay, that's fine. Well, thanks for joining us. Okay, so yeah, I was just talking about Peach Jam in Atlanta. I think that's coming up in a couple of weeks. I haven't registered for it or anything. Let me share my screen. So yeah, it sounds like a good time. Yeah, I just didn't know if you bring your own PC or if they provide that or not. I noticed that Drew Ragsdale, he was joined us, I don't know, earlier this year, and he's been working some more on his space shooters. I'm not sure exactly which is the latest one. He has one called Cyberspace Shootem Up. It looks pretty cool where you can select your ship. I guess the ships have different properties. I think he works in GameMaker. This is all done in GameMaker. I think he does a lot of Udemy tutorials. I think he gets a lot of code and examples in there. Here. So I'm not sure if that's his old one or new one, because when we did the when he had the retro game, or maybe this is the same thing, he did show us a while back. So maybe he just has one game. Let's see here. And it looks like he's been doing some GameMaker 2 tutorials over the past few days. So I'll post a link to these on the Knox Game Design website. I haven't watched these myself, but it looks like he has quite a few. And it does look like these are GameMaker Studio 2. So I guess if anyone's wanting to make the transition from GameMaker 1 to GameMaker 2, these may be a good resource. It looks like these are like between 2 and 10 minutes, so definitely something you can probably watch in one sitting. I did have somebody send in an email asking or suggesting that we have a Discord, so maybe I'm not promoting it very well, but yeah, it's right here on the website, the second block over from the top. You just click that, and I think that will give you the link. That'll give you the link for the invite to our Discord server. So that's continuing to grow, and yeah, that's where I'm posting a lot of the stuff. So if you're looking for the slides, I always try to post out the slides before the meeting, just so people have that as a reference. Okay, so the topic for this month is C with SDL, or SDL with C. This is kind of more like a history lesson here. So basically, SDL is the simple direct media layer, and this was like I don't know. I think the first release was in the late 90s. Yeah, 1998. So before GameMaker and before Unity. And this is a game like library framework that I used. I don't know, in the early 2000s. I developed a couple of games, Legend of Tux and Tetris City. But I think I developed those a few years later. I think I did some early stuff in SDL, though. And you can find those on, let's see here, SourceForge. Yeah. Okay, so it was created by Sam Lantinga. He's worked at Blizzard, Valve, and World of Warcraft. So it's pretty cool. Like, when I use these libraries, then I looked in the credits, like, oh, this is a guy that actually worked on World of Warcraft and stuff like that, which is pretty cool. So one nice thing about SDL is one set of libraries, but they have what they call bindings for multiple languages. So bindings basically means, well, you can download these libraries for like Ruby, which I did that Tetris City game in, or Python, and you can use the same calls, it's just in different languages. So that's always cool. So the games used in SDL, like one game that I really liked a long time ago was called Chromium BSU. That's also on SourceForge. You just look it up, Chromium BSU. Simple little shooter game. And also on the SDL website, they list a whole bunch of games that have like either used or been developed in SDL. So I think like some of the ones they claim may have used SDL to port their game from Windows to Linux or other operating systems. I think they have builds for Linux, Mac OS, and Windows. And also emulators such as DOSBox, those run on top of SDL. So pros and cons, SDL with C. So this talk is going to be focused on using the C language, which was like still a very widely used language. It's a good language to know if you're planning on going to college and everything, because I know like a lot of universities start out with C, or they have C as a part of the program. So pros of SDL with C, you have really low level control. You can go in there and manage your own memory and free up your own memory and really get down to the metal, as we used to say. You only use what you need in SDL, so they have like a core SDL library, and then there's all these additional SDL libraries that you can add in, such as for fonts and for music and other things like that. It's really fast. So when I've been developing a simple game as an example, and compilation takes like a matter of seconds. Whereas if you're developing in Unity or GameMaker and you press build, it can take maybe a minute or two, depending on the size of your project. So it's very fast for a comparable game project size. Small executables. I know in the simple game I developed, it seems like it's just like a few megabytes, where if you develop anything with Unity, I think it's going to be like 80 megabytes or something crazy like that. So it's small executables, which makes those games easily distributable. It's totally free. You can download it and use it. I don't think you have to include any attribution or anything like that. It uses what's called the zlib license, and everything that I'll be talking about today is for SDL2. I think the SDL 1 or 1.4, I think it used the GPL, but it seems like everybody's like moving away toward the GPL now. But yeah, I think the zlib license is kind of like the MIT license, or it's just like, okay, do with it whatever you want. So it's pretty nice. It doesn't put any splash screens or doesn't put any ads or anything like that. So you're just free to use it as much as you want. As mentioned earlier, it's multi-platform. You can use it on Windows, Mac, or Linux. They may have it for other platforms like FreeBSD, but I don't know. And you can also do 2D and 3D. Today I'll be primarily talking about the 2D SDL, but for that Tetris City game that I did years ago, I did do that in 3D using OpenGL, but I think that's talk for another day. Could do one talk specifically on 3D. The cons of SDL with C can be a little bit complex to set up. It's not hard, but it may take you, I don't know, probably maybe an hour or two to get it all set up and running. Whereas if you're using Unity or GameMaker, I mean, you're up and running in a matter of minutes. You can run into issues when you're allocating your memory, which if you don't free up all your memory, that can lead to memory leaks, which is not a good thing because it continually starts eating up memory if you don't free your memory. There's no garbage collection like in languages like C# and Java. Once you are no longer referencing an object, then eventually those get flagged for deletion. When there's nothing pointing to an object, those get flagged for deletion. That's kind of a good thing and a bad thing. The good thing is you don't have to manage that yourself in a garbage collection language. The bad thing is sometimes the garbage collector comes around at a, less than optimal time, so you can notice a lag spike in your game because the garbage collector is running. So garbage collection is basically just whenever all these things that no longer have pointers or references pointing to them, they get freed up so that memory can be used for other things. A lot of game frameworks hide the messy details in C or SDL and C. You pretty much have to do everything yourself, like allocating your sprites and allocating music and freeing those up and things like that. And anything beside the basic operations require libraries like out of the box, a quote-unquote box. SDL will handle joysticks, it'll handle keyboard input, it'll display sprites to the screen and things like that, but music and fonts and other things like that require additional libraries, but like I said, those are all also freely available, and they aren't too difficult to install. So getting started with SDL, you can go to the website. It's just libsdl.org. So yeah, and these are some of the games over here that they have listed. But yeah, current version is 2.0. But yeah, you just click on, I think there's download SDL 2.0, and they have the binaries. So if you're wanting to play an SDL game, all you need is the binaries. But if you're actually developing a game in SDL, you got to get the development libraries, which are a little bit lower down. You can either get them for Visual Studio or MinGW. Today I'll be using MinGW. I tried doing the macOS installer, but I couldn't get that to work. And Linux, I was able to get that working. I'll talk about that later on in the talk. So yeah, you just get those. It'll give you a tar.gz file. You also want this program called MinGW. It's kind of like Cygwin. Let's see here. MinGW.org. Uh-oh. What was that domain? Huh. Oh, maybe I put an HTTPS on there. Let's see here. Copy link. MinGW. Wow, that's kind of interesting right there. It's pending. I can't verify. Well, this was up and running the other day. That's very bizarre. So yeah, hopefully they get that back up and running again. But yeah, you just download that, and it'll give you like a little bash prompt right here, and you can do all your standard. So it's basically a Linux or Unix simulator on Windows. So it'll give you a prompt. You can do pwd and ls and cd and all your standard Unix commands. If you want to do VI, it has VIM. So one thing that I always do is I set up an alias in my .profile. So I just set VI equals VIM. You can also do that from the command prompt by just typing alias. VI gets VIM in single quotes, and you can just type VI and run VIM. So yeah, I recommend learning VI for anyone getting into software development because it's standard on all Unix and Linux systems. So yeah, you run the installer, and it'll ask you which packages you want to install. The one you want to grab is the MinGW32 GCC.bin. GCC is the GNU C compiler. So you want to make sure that's installed and working. So yeah, just run mingw msys 1.0 msys.bat and they'll give you this prompt right here. So I can type gcc right there. And I don't have anything to compile right here, but it verifies that that's working. So yeah, first thing you want to do is test your C compiler. So I think I have a simple C. Let's see here. Do I still have hello.c? Yeah, I guess I don't have hello.c anymore. So I'll go ahead and do like a simple hello.c. So you want to pound include standard.io, and that just does your input and output. So you can use commands like printf. And your startup function is main. You can pass parameters to main, such as argc, which is your argument count, and argv, which is a string array of your argument values. But just print to your screen, just do printf, hello world, do \n to add a new line to the end of that. And then int always returns a integer. So yeah, I'll just return 0. 0 is for success, and 1 or anything greater than 0 is an error code. So to compile this, I'm just going to do gcc and use -o to output. So I want to output to the executable hello, and the file that I'm compiling is hello.c. So run that and do a dot forward. Oh yeah, the sometimes the virus scanning thing doesn't like it when you use GCC. So let's see here. Norton, let's see here. I can handle this real quick. Oh, view details, okay. Removed restore, okay. I want to allow that, yes, okay. So run hello, and then it says hello world. So we verified that our C compiler is working. Yeah, so I made a note right here. Some virus software may flag the executable, so restore it if needed. So I think it's just because it's a new executable, it doesn't know what it is. So some virus scanning software will think that it's a threat. So C differences from other languages. I actually had a book. Where's my book? Let me go grab it real quick. Yeah, so there's a book called The C Programming Language by Kernighan and Ritchie. If you're into like a hacker jokes and things like that, that's a good book, a good reference. Those were by the creators of C. The one that I like is C in a Nutshell. The O'Reilly books were really good. So this is a really good reference of all the different commands and libraries and things like that. And also just a good overview of pointers and things like that. So I recommend C in a Nutshell if you can still find it. So let me go share that back out. Sure. Let's see here. So you don't have, like in C#, you have a const command. It's kind of like a global. You don't have globals, but you can use the pound define for constant. So I think pound define will basically, it's a directive to the compiler just to do a simple text replace. So if you do like pound define screen width, give it a number, then it'll replace that anywhere that you use screen width with that number. There's no concept of a bool, but you can set an integer to either true or false, with true being 1 or false being 0. You got to watch out, like I mentioned earlier, like when you're returning a code from a function or from a program, 0 is success and non-zero is failure. So it's kind of the opposite of a true-false statement. So if you're doing an if or while statement and the result is a 1 or anything greater than 0, then it equates to true. There's pointers and structures instead of objects and references, like in C# and Java. With object-oriented programming, you have references to objects. There's no objects in C, but you can kind of emulate them with structures and pointers. One thing you got to look out for whenever you're defining a method, you got to define your function prototypes up at the top. Otherwise, your compiler will get angry and yell at you and sometimes not compile. I think it's just a way that it compiles. It has to know ahead of time what the definitions of the functions are before you actually get into the function definitions. So structures are like a object. You can hold multiple data types. I think they can also hold pointers to other functions. I haven't tried that. Now here's a big one right here. There's no dynamically sized data structure like a list or a vector, but you can make your own with linked list, which is one of the things that I'd been working on over the last week. So that was a lot of fun. I'm just trying to go back and freshen up my C skills, just because it's been so long since I've done anything in C. Another thing you got to watch out for, especially with the GCC compiler, is don't assume that your variables are automatically initialized to 0 or a false. Sometimes they're just set to some really weird values. So if you're going in and you use a variable and it's like, oh, why is my ship off the screen or something? Well, it's because it wasn't initialized to 0. So you got to manually assign all your values to 0 or false. There's no string structure, but there is a character array, char star, or you can use the square brackets for your character string. There's no functions natively built in, but there is a string library that comes standard, so you just have to #include string.h, and using that you can get like the length of the string, or I think there's a substring. I can't remember if there's substring or not, but you can like get in. I think you can do things like get indexes of characters and things like that. And there's no inheritance or subclasses like in object-oriented languages. So yeah, just going to do a brief overview of pointers. I did a simple program here explaining how pointers work. So basically, a pointer is pointing to is an address in memory, pointing to a location of memory. So you can like make a pointer to an integer or a pointer to a structure, and that becomes really helpful when you're doing these. When you want to make a new structure or make a new integer, and you don't want to have it static. So if you want to have a variable list or things like that, that's where pointers are really helpful. So doing an int star p, that'll create a pointer to an integer value, where p is the address of that in memory. And if you want to get the value of p, then you just use star p. So you can see that in the code right here. And one thing you got to do is, like, whenever you create a pointer, you got to allocate that memory typically using malloc. This isn't the best code here. You're actually supposed to test and ensure that malloc returns a value. If it equals null, it means that you ran out of memory, and you should handle that. But you can use the size up operator to get the size of an integer. Typically that's 1 byte, 8 bits, but it may vary on different systems. So yeah, you can print out the value using that star of p, and the address of that in memory, you just do p right there, and they'll give you a number of that place of that object in memory, or that memory, yeah, the address of it in memory. And yeah, after you malloc, you always want to free the what you've used, so that memory can be freed up to do other things. And that malloc and free, that's part of the standard lib.h. You got to remember to include that if you want to use that. Dereferencing a null pointer. So if you declare int star p and that's not pointing to anything yet, trying to do star p to get this value, that will result in a crash or a core dump typically. And also allocating something that's bigger than the memory that's been allocated for it will also result in failures. And you can also use the ampersand character in front of your pointer to print out that address location in memory, which is kind of helpful sometimes, so you know exactly what things are pointing at. SDL will help you with some of this, like when you're allocating sprites and surfaces. It has specified commands, specialized commands to handle allocating that for you, but you still got to remember to free those up, which have commands to do that as well. So to set up the SDL libraries, you got to start min-gw, and then you want to copy that tar file into temporary directory, extract it out, then cd into that new SDL directory, which currently is SDL2-2.0.10. And then all you got to do is type run make native, and then it handles everything else for you, which is pretty nice. So your first thing you want to do is try to just like get a window up and running. You want to initialize SDL with the SDL init, and you can pass various parameters to that. Typically, you just want to pass in SDL init video, but I think there's like some alarms or something which you can set up using like a pipe, and you pass in additional parameters separated by a pipe. Then to create a window, all you got to use is SDL underscore create window. And there's a whole lot of parameters to that. I typically use the default, but you can change the first parameter to be the title of the window. And then it looks like the fourth and fifth parameters are the width and height of the window. And after you do that, you can get a reference to the window memory to draw on by using SDL get window surface. And just to draw a rectangle, you can use SDL fill rect. So in this example code right here, I'm just drawing a cyan color rectangle on top of the screen, and it delays for 2 seconds. And so yeah, you can use this SDL map RGB to pass in the R, G, and B. So setting G and B, which is this 0xFF, which is 255 in hexadecimal. So that's 0 red, 255 green, 255 blue, which is cyan. So it just basically draws this cyan colored rectangle right there. And then you want to like update the surface, window surface, with SDL update window surface. Then I added a little bit of delay right here, 2000 milliseconds, which is 2 seconds. So it doesn't immediately pop up and close. So then after you're done with the window, you call SDL destroy window, and then SDL quit, which shuts everything down. So yeah, after you got your window up and running, you want to use to display a sprite or an image. SDL calls these surfaces, which are basically sprites in other languages. So you use SDL load BMP to load a bitmap sprite. It can only load BMPs, like standard Windows BMP files by default. If you want to do pings or JPEGs, there is a standard SDL library for that. It's just another thing you just got to go out and install, which isn't too bad. So they have a thing called the color key. So by default, BMPs don't have transparencies, but you can set a specified pixel color to be transparent. So typically I use magenta, which is all red and all blue and no green. So you can do SDL set color key to magenta to set that as the transparency color. So whenever that sprite is drawn with that color, key, then it won't display that magenta colored pixel. Which I have an example of this little squid alien guy right here. That hot. Some people say it's hot pink. So this hot pink type color it won't display. So yeah, use SDL Blitz service to display your sprite to the screen. Here I have a simple hello world. And later on I may talk about it a little bit, but this is good for starting out, but typically what you want to do is push all of your sprites, your surfaces, to the graphics card. So you'll use these commands SDL renderer, or which is actually a structure, an SDL texture and SDL render copy, and replace those surfaces with textures, which are actually running on your graphics card instead of your CPU, which is a little bit more efficient. It makes your game run a little bit more stable. So your game loop, basically you're going to have a big while statement that runs forever, and for every time that while loop goes through, you're going to do an SDL pull event, and you're going to pass it a reference to an event structure, an SDL event, So you use the ampersand to pass that reference by the address. You want to stop looping whenever this SDL event equals SDL, the event type equals SDL quit. So when I first started out with SDL, I would put everything in this game loop, all my update code and all my draw code. And years ago when I didn't know any better before I really started making games, but after like doing XNA and Unity, I realized it's better to have an update function and a draw function where you do all your game logic in update and all your draw calls in draw. So for this little simple game that I developed, I created like separate update and draw methods, which seem to keep things a little bit more clean. To detect keyboard presses, that SDL event, you just check the type, and if it equals SDL key down, then that means the user has pressed that key, and you found out what key they've pressed by using keysym.sim, and then there's constants defined for each of the keys. I think it's just like SDL, like A for A, or SDL Q for Q. You can also call SDL delay. You probably want to call that on every update. Typically I use SDL delay 16, which means delay for 16 milliseconds, which should keep your game running at 60 frames per second. However, you really want to subtract off the amount of time that you've been updating and drawing, which that can get a little bit I don't know, complex. Sometimes I tried doing that, and that led to a few crashes. So I just replaced that with an SDL A16. Otherwise, if you don't put an SDL delay in there, then your processor will continually spin, and it will try to run at like 400 frames a second, or however fast your CPU can run. You can calculate that delay time using SDL get ticks. That means the number of ticks that have passed since the last loop. Okay, so basically you get a ship moving around. You want to create an SDL rect, a rectangle, and then that will be used as the destination parameter of SDL blitz service. So you're going to draw into that rectangle. So yeah, the SDL rect will hold your X position of your ship, the Y position, the width, and the height. So it is very important, like I mentioned earlier, none of these are initialized, so you can't assume that X and Y will be set to 0. So if you want to draw your ship at 0, 0, make sure you set your X and Y to 0. And then you can use SDL update window surface. I think I mentioned that earlier, to update the screen after you're finished drawing. The good thing about SDL, it does handle double buffering. Back in the day, like in QBasic and some other languages, it wouldn't handle double buffering, so it would pop things in on the screen as they're drawn. But what you really want to do is draw to an off-screen image, then flip that entire image onto the screen. So that's basically what this update window surface is doing. I think in SDL 1.4 it was called SDL flip. So if you do have an SDL 1.4 game and you want to upgrade to SDL 2, you may have to change SDL update flip to update window surface. One thing you got to check out is to clear the entire screen. If you're not drawing the entire screen, then you can get like this smearing effect with this ship. So another way to handle that is called SDL render clear, and that will make sure that everything's cleared. But if you're already drawing in a background image, you don't have to worry about that. And some of the extra things I like to add to my ship structure is like the velocity, velx, vely, and is alive to see if it's alive. And I have some code examples over here of the ship structure that I used, and also handling the input over here to the right. Let's see if I have. So I had a test over here. I'll go ahead and bring it up right now. So I'm in test game. So test game 00. So this is a basic example right here of just drawing a simple ship to the screen, and you can use the keys to move it around. And you can see here I haven't set the color key yet, so you do see the magenta color in the background. And test game 01. It's the same thing. Yeah, I'm not exactly sure the difference between that. It is checking the boundings, and also you need to handle, like when you get SDL quit, make sure you exit out of your game loop right there. So test game 02. This is like where I've initially got the background working. So I basically had a 255 by 255 image, which I'm continually scrolling downward. I got the ship right here moving around and an enemy, but you can see there's no collision detection yet or anything. But do have the bound checking. So when I'm making a game, I typically go through this process, just adding one thing at a time, getting one thing working, and moving around. That's kind of like how it all starts. So in test game 03, basically got the enemy moving around. So he's basically just going to move left and right. Still haven't got any collision detection working right here or anything, but it's just one step forward. Let's see what my next slide is here. And so in the next version, test game 04, I got shooting working. So basically this is just another structure for a bullet and keeps track of the bullet's X and Y position. But you can see here there's still no collision detection. You bumping that guy and nothing's going to happen. And close that. Test game 05. So this is where we actually got the collisions working. So now whenever I shoot and the bullet intersects with the enemy, then it's going to delete the enemy. And later on it'll add to the score and things like that. So add an enemy. The enemy is going to have a similar structure to the ship, an X position, a Y position, health, which I'm currently not using. I usually add a float for a lifetime just to know how long that enemy's been alive. That's kind of helpful when you're trying to position an enemy. If you want him to go like in a sine wave or something like that, you can use that lifetime to detect the position of the enemy where it needs to be. And also is alive, which is good. That way you can flag them to be not alive, then handle some cleanup before you actually delete the enemy. So as there you can see, got the back and forth movement working. So yeah, after I use that lifetime, after 2 seconds, then he's going to start going the opposite horizontal direction. The bullet's similar, has an X and Y position and is alive. Also, you want to make sure if the bullet goes outside of the screen, then you want to set the is alive to false and also free up that memory for the bullet. And you only want to draw it if is alive is true. So yeah, that's basically how you get started. Just get your ship moving, get an enemy on the screen, get a bullet shooting whenever you press space, and do the collision. This is some very simple collision detection here. So the first thing I worked on was getting the collision between the enemy and bullet working. Then you can get the collision between the enemy and ship. I don't know if that was included in the last version I just showed. So if I had the ship, so if I run the ship into the enemy, then it's going to collide and destroy itself. I do have source code for all of these. So VI test game, and I'll put these are posted on my GitHub account. So on VI, the source file. So here's like the prototypes I was talking about earlier, where you define those. Here's all the surfaces for the ship and the enemy and the bullet in the background. Have a structure like I talked about earlier for your ship, and your width and height and things like that. Let me check this over here. Okay. Here's the enemy structure, as I mentioned earlier, all its properties and the bullets. So basically I just start with one ship, one enemy, one bullet. Here's a keep looping, which I think I took this out in a later version. That's just to make sure the game loop is still working. And this background offset is just for scrolling the background. It keeps the offset. Once it gets above 255, then it gets set back down to 0. So I initialized the ship and the enemy and the bullet using those values right there in a start method, which gets called on the first leap of the game loop. Then an update, which basically moves the ship based on its velocity. And this code right here basically makes sure that the ship stays within the screen bounds. If it's less than 0, then it pushes it back in. If it's greater than screen width or screen height, then it pushes it back in. And here's the enemy. It's like where I'm adding, this isn't perfect code right here, but it adds 0.2 for every update. Then once that gets over a certain value, then it starts going back the other way. And here's where I was updating the background right here. Then I call check collision. So check collisions, basically, this is a very simple blocks collider right here. It's basically going to check and see if the X and Y position of the bullet is within the bounds of the enemy. So if the X is greater than enemy X and it's less than the enemy X plus the enemy width, and also if the Y is greater than the enemy Y and less than the enemy Y plus the enemy height, then it's collided. So then we want to set the bullet to false, is alive to false, and the enemy is alive to false. Got the same thing for the ship here. The downside of this code, like I said, it's very simple. It's only going to check and see if the upper left point of the bullet or ship has collided with the enemy. So in a later version of this, I actually changed it to where it moves that collision point to the center. If you want to get even fancier, then you could actually do the box collision between the two. But typically, if you do the center, that's pretty good. And I talk a little bit about the collision types on that slide. Here's all the key up and key down handlers right here. So they got these constants defined for up, down, SDLK up, SDLK down, SDLK left and right. So you can handle those key presses appropriately whenever the key is pressed down. Or if the key is up, then you can also handle those. Like if whenever you let the arrow key up, you set the velocity back to 0. Here's the draw method where you're using the SDL blitz surface to draw the background, and draw the ship sprite, draw the bullet, and draw the enemy. And also the shoot whenever you press space, and it's going to set the bullet to live as true, and set the X and Y position of the bullet to the location of the ship. And here's the main method, which this is the entry point to your program. Yeah, I think in an SDL program you have to actually specify argc and args, otherwise it will complain. But yeah, your SDL initialization, we're loading the bitmaps through here using SDL load BMP, and here's the game loop right here. This one I just have an SDL delay of 1. That's probably a little bit too fast right there. So yeah, that's the basic structure of an SDL program. Some other types of box collision. So I basically did a simple box or rectangle collision box. Circle collision detection, you can use the Pythagorean theorem to determine if two objects or how the distance between those objects are. So you can, if two objects are less than a certain distance apart, then you know that those two objects have collided by the Pythagorean theorem, which is a squared plus b squared equals c squared. So basically it's the difference between the x components plus the squared plus the difference between the y component squared, and then you take the square root of that, and that'll tell you the distance between the two objects. There's also pixel perfect collision detection. I think that's usually overkill, but you can actually go in there and see how many transparent pixels you have, and sometimes you can like subdivide those and then determine, but that takes a lot of processing power, and yeah, so I typically would stay away from pixel perfect collision detection. And then there's also continuous, kind of like in Unity, you can have a continuous collision detection for very fast moving objects, because sometimes you have the problem, like a very fast moving bullet will be on one side of an object on one frame or on one update, then the next update it will be on the other side. So what you got to do is calculate to determine if that bullet has passed through the other object. But yeah, typically you don't have to worry about that unless you're doing really fast objects. As I mentioned here, this is like the structure of an enemy right here. Starting out, I just do an enemy array. So I just create like an enemy array of 5 objects, and you can manually assign the properties of those objects and then insert those into that array. Later on, I'll talk about linked list. You can create a method to like initialize all these, then you pass in a pointer to the enemy and then set the initial values there. But yeah, you do have to use the ampersand to pass a reference to that, and not the structure itself. I think if you pass the structure itself, you lose that reference whenever you pass it into the function. Okay, so yeah, that's the structure. You can use the hyphen greater than symbol. It looks like an arrow to dereference a pointer and get its value. So if you have a structure enemy star, then you can allocate that enemy with malloc, then the size of the enemy structure. So that will give you a chunk of memory that's the size of an int, like for the health, then int for the X position, then for Y position, then width and height, and float for velocity X and float for velocity Y. So allocate a chunk of memory that will hold all of these values right here. So then you can just reference these different properties using that arrow operator. So yeah, if you want to print the X and Y values, just use printf, and then you pass it a string, and you use the %d to print out integers, and then you pass those integers as parameters like enemy X and enemy Y. And also, enemy and arrow X is the same as like dereferencing that enemy object, then put that in parentheses .x. So it just makes it easier to write that. Linked list. So linked lists are dynamically sized data structures, kind of like a vector in Java or a vector in C++ or a list in C#. Typically, you have a reference to the head of the list. You don't want to lose your pointer to the head of the list, otherwise you've lost your list forever. Each element, which typically you call nodes in the list, has a pointer to the next element in the list. So then you can iterate through this list by continually calling next and then stopping once you get to null. You can add elements by iterating. Okay, I already talked about that. So this gets a little bit tricky. If you want to remove an element to the list, basically you take the previous element, point it to that current element's next element, then free that current element. And one nice thing about a linked list, you can define an anonymous data type, which is a void star pointer. And then you can assign any structure of any data type to that void pointer. You just got to make sure you cast it whenever you access that. So let me go back to my screen here. Let me go up, CD, then I want a VI, linked list. And a lot of these definitions you define in a header file, like linkedlist.h. So here's the structure definition of a node structure. Basically, it's struct node. You got a void star pointer data, then a structure node pointer to the next value in the list. So if I do vi linked list.c, then I have various methods I define, such as add node for adding a new node to your list. If you want to remove a node, a specific node, or just remove the first, which is kind of like a first in, first out. So you push new nodes on, then you pop them off, pop the first one off. There's other like methods for adding and deleting, like pushing to the end or popping from the end. But yeah, this one works pretty good just for a simple game. So that's one downside to C. You have to like write all this code yourself, but I'm putting all this code out there on my GitHub, so if anyone wants to use this or copy it, that's perfectly fine with me. I think there are some places for improvement, like when I remove a node, I free the node, but I'm not freeing the data for the node. So I think that's one improvement. But I think you got to make sure that data has actually been assigned to something first. Here's a method for printing the values of the list, assuming that the list is a list of integers. You can actually pass in other data types. We'll just print like the first value. I was writing this last night for completely clearing an entire list. And this will count the count list will count the number of items in the list. And then I have like a lot of different examples of how to add values to the list and how to remove the different values from the list. So check those out if you're interested in that. But yeah, that's very helpful. Like if you're making a game, you want an unlimited number of enemies or a variable amount of enemies, and just add to the list and then pop them off as you defeat those various enemies. So the next thing you'll probably want to do in SDL is drawing text. So you got to download that library for that, and you can get it off the libsdl.org site. You'll download a tar.gz file for SDL TTF Devil 2.0.15. And it's pretty easy. You just extract that using tar xvf and the name of your file. Then all you got to do is run make native, and it automatically builds it and links it and everything for you. One thing you got to watch out for is whenever you're compiling, you got to pass in the -L SDL2 underscore TTF parameter to your compiler when you're compiling that. You also have to do the #include SDL TTF in top of any of the files that use that library. And you also have to use TTF init at the start of your game. There's a lot of documentation for that. Let's see here, copy link and paste that. So you can go, they got the documentation in a lot of different formats. I kind of like the Acrobat right here, PDF, but it'll give you all of the different commands for TTF, but typically TTF SDL libraries, but typically I just use a few of these. So let's see here. You can build a string with sprintf, which is I'm not sure if that's part of string. I think that's part of standard IO. But yeah, one thing you got to watch out for is like whenever you're allocating the memory for a texture, for a text texture, you also have to free that up as well. So if you're drawing on every frame, if you're creating text every frame, then you're going to continually allocate memory on every frame if you don't free those up. So typically it's good to only create a text texture whenever your text has changed. And one way you can check this out is if you go into Task Manager under Windows, and if you're not freeing your textures for your text, then you'll see your memory usage expand exponentially. So here's like a little test game right here that I wrote, and it's already up to 250 megabytes because I wasn't freeing the texture for the text. So yeah, just watch out for that. But yeah, if you're wanting to make a string like hello world and pass in a value, use sprintf for that. It works very similar to printf. To play sound and music, you use SDL Mixer. Load and play audio is another library you can download from the same location. Just make sure you pass in that -SDL -L SDL Mixer to your compile flags, and add the #include SDL Mixer to your source code at the top of the file. Use Open Audio to initialize it. To load in WAV files, you use load WAV. I think by default it only loads WAV. I think it can do MP3s as well. If you got music files, which are kind of the same thing, you can use play music, but it has some different properties which are good for looping instead of just playing sound effects, which you would only play once. And you can also use this play channel to play on different channels. But I think I usually just have that set to a -1, which uses the default. Distributing your SDL game, you want to get the exe that's been generated, then all your image files and the DLL files, you put all those into a directory. Or you can just grab the DLLs off the libsdl website. You also want to include any other DLLs, such as your TTF DLLs, zlib, and FreeType DLLs, which are also required by the TTF library. You can download those off the libsdl website as well. And include any TTF or WAV file. What I did is I put those in a separate directory. See, LD Smith projects. SDL. Yeah, this game is called SDL Shooter. So basically just put in like my executable SDL Shooter right there, then the DLL files, put those in the same directory. I had a problem moving the TTF font file to a different directory, but all the other assets I put in a folder called assets, like the audio. Here's all the WAV files right there. And the images, here's all the sprites here. I actually created all these sprites in Asprite, which I talked about, I think, a year or so ago. So you really don't need to include these ASP-write files, just BMPs. Yeah, so one thing you got to watch out for, there's both 64-bit and 32-bit libraries. I don't think MinGW does 64-bit right now. So I think those are only for Visual Studio. But one bad thing, if you try to run your game and it doesn't work, make sure you're not mixing the 64-bit libraries if you accidentally downloaded those with the 32-bit. You can tell whether it's running 32-bit or 64-bit by going into Task Manager when running your game. And if it has 32-bit next to it, then you know you need to get the 32-bit libraries and distribute those. Yeah, because I think it can be kind of hard to try to find those DLLs within your game hierarchy. So sometimes it's better just download those from the website. So yeah, when I was starting out, the code that I just showed, basically I had everything in one file. But one thing you probably want to do after your game gets so big is break up your code into different files, kind of like in Java or C#, where you have a separate file for every class. Basically, I put all the logic for like a ship in its own file, ship.c, put all the logic for enemy and enemy.c, and all the logic for bullet and bullet.c. You just got to make sure that like your update command and your draw commands and everything for those have unique names. You can't use the same names between files like you can in C# or Java. So in a way, you can kind of simulate object-oriented programming that way, just keep everything separated and clean. So in each of these files, like I said, I have an init, update, and draw function. So yeah, if I look at the code here, let's go back and like look at ship.c. So I have an init ship, an update ship, and a draw ship. And so for like an enemy, vi enemy.c, I have a init enemy, update enemy, and a draw enemy. So I kind of use that same format for everything. Now in the enemy's case, I have two different types of enemies. So I have a switch statement in here. So it kind of, based on the behavior of the enemy, I use that switch statement right there. If you want to reference a function from another file, you got to make sure, this is something I didn't know about when I first started learning C, but you got to use extern, then the name of the method or the name of the variable that you want to use. If you don't have extern defined, then your compiler won't know, it won't recognize that variable or function. Like I said earlier, you want to put all your function prototypes and things like that, your structure definitions in H files typically. That way you can include those in other files so they know about the data types. And also, one thing you got to make sure, look out for is like any file that makes SDL calls, you got to make sure you do a #include SDL.h in every single file. One other feature that I added to this game is the ability to read the formats or the layout of the enemies in data files, and I just have a simple text data file. You read a file, you using the file star pointer, make a call to fopen, pass in the file name, and then typically I just use R as the second parameter, which means open it in read-only mode. Then you can get each line in the file by calling fgets and then pass in a character array, plus the number of bytes you want to use. Read, I typically use 64, and then pass in the pointer to your file reader. Then after you're done reading all the lines, eventually this fgets will return null. So once that returns null, then you want to call fclose on the file reader. You can access individual characters in your character array using array notation, which is pretty useful for looping over that string. And also, one thing I found out is like you need to add the -m console flag whenever you're building. This really doesn't have anything to do with reading files, but if you want to see the output when you print things to the screen, you got to add that m console. So let's look at that really quick here. So vi file, read file. I don't know what it's called. I'll say level reader, level reader.c. So basically, this is where I'm reading it and opening the file and parsing through all the characters right here. So whenever it sees like a 0 or a 1, then it instantiates a new enemy. So if I vi level 00.text, these are the formats for all of the enemies. So this is the first level between these equal signs. This is the second level, and this is the third level. So you can see them like in this triangle structure right here. So if I run SDL shooter, you can see they're in that triangle format right there. But I can go in, like, edit that level file, and let's say we want to delete this second row of enemies, and then we can run it again. And that second row, actually, it's offset a little bit right there. But yeah, it'll basically read through that and set up the enemies according to that notation right there. Yeah, I think it didn't like it because I deleted all the characters at the end. So one other thing is make files. So whenever you're building a game, typically I started out with like a script, but eventually you want to put your stuff in a make file. That way, whenever you build, you just type in make on the command line, and it will compile your file. So whenever you're making a make file, the first line, well, you can set up these like aliases, I guess, up here at the top. So your C compiler is GCC, your executable is SDL shooter right here. So the first item on the line is your name of the executable. So anything on this, whatever this is at the first, on the far left side, it depends on everything to the right side of the colon. So your executable depends on all of these C files. So if any of these C files change, whenever you type make, it's going to rebuild your executable. Otherwise, if none of these have changed, then it's just going to say it's up to date. So I'll do an example of that. So if I type make, it's going to say SDL shooter's up to date. But if I vi SDL shooter.c, and let's just say I just added like new stuff right here, then I type make, then it's going to build it all over again. So then if I type make again, it's going to say it's up to date because I haven't changed anything. So yeah, making make files is pretty nice, especially when you want to port this over to Linux or something else. You can just like give somebody your make file, and then the person can just type make, and it'll build the whole thing for you. So yeah, talked about that. You want to make sure on the second line, which is the thing to be executed, it starts with a tab character. That is very picky on that. You can't do a space. You can't do anything else. It's got to start with a tab character on your second line. And also, there's a little trick. If you want to compile your C file into object files, you can use -C, which is kind of like an in-between from your executable from source. So you can compile them into these intermediate .o files, and then you can have dependencies for all those for compiling your C files into object O files. Just have a few more slides here. So yeah, last night I verified I was able to build this game on Linux. It's pretty easy. It's easier than Windows. The C compiler GCC was already installed on the system. You can install the libraries, like where I was downloading the libraries and extracting them on Windows, on Linux, and I was using Ubuntu Linux. All you have to do is sudo apt install, then the name of your library. So in this case, it's sudo apt install libsdl2-dev, and they'll ask you, do you really want to install these? And you just tell it yes, and it'll go through and install that for you. Then all you have to do is, like, I have a specialized line for the Linux build, because one of the parameters is different. It didn't like the -m console, so I just have a make Linux. Just type that, then it'll build your executable, and you're good to go. So yeah, and these, like, what is it, like 8 to 10 lines right here that that'll build your game under Linux. Like, you can use this one command called apt cache search, and that will look into the list of available libraries to see what the libraries are out that you can install. So you can pass in libsdl to find all the libsdl files. And finally, I didn't mention anything about random numbers, but you can start a random, because I didn't have any random numbers in the game in that build. But you can generate a random number by using the rand command. You want to, if you want to seed that to a truly random variable, or not truly, but somewhat random variable, you want to pass it in the current time in milliseconds. So you can use time null, pass that to srand, and that will randomize it to a new value. Otherwise, if you don't press that and you use the same seed every time, then you're going to get the same random numbers every time. And by the way, that isn't truly random because time null only updates every second, so it's only going to generate a new random number every second. I verified that with a little simple number guessing game. I probably should have started out with this instead of the other stuff, but vi numguess.c. So here's where it's just printing some random numbers between 0 and 5 and exiting right there. But yeah, basically you have a hidden number. You're going to grab it from rand. Then to make that a value from 1 to 100. And yeah, if you want to learn all about random numbers, I did a talk on Knoxville Game Design a few months ago. Just look up RNG, Knoxville Game Design Random Number Generator, and you can find that whole talk about random number generation. But you basically mod that number with 100 to get a value 0 to 99, then you add 1 to make it 1 to 100. Then you have the number of guesses, set that to 0, and the guess value to -1 just to initialize it. So while the number you've guessed doesn't equal the hidden number, then you're going to ask the user to select a number, enter a number, and then based on whether that number is greater than, less than, or equal to, you're going to print higher, lower, or correct. And then you want to increment the guesses by 1. So I can do GCC output numguess numguess.c, then run numguess.exe. That's where it's just printing some random numbers up there. So I want to guess 50. So it's going to say lower. I'll guess 25. Lower, guess 12. Lower, 6. Wow, lower 3. 2. So the number was 2, 6 total guesses. Let's try that again. 50, higher, 75. Lower, 62. Lower, let's try 59, lower, 55, lower, 52, higher, 53, 54. So the number was 54, 8 total guesses. Okay, so that's all about random number generators. More information on SDL. There's the libSDL forums right here. Paste that in here. The one nice thing is the forums are active, so it looks like there's people out there that are asking and answering questions, and yeah, just like 4 hours ago, a day ago. So this is still highly active. A lot of people, looks like there's still a lot of people developing in SDL out there. Documentation wiki, where you can find out about all of the SDL functions and things like that. You can go here and go to the API reference, and they'll give you a list of every single function in the library. So if you're looking up for the specific parameters to use, and a lot of them have code examples right here that you can use. I think that's basically what that was. There's a lot of nice tutorials out there. I think the best one out there is this lazyfoo.net. So paste that in, and it'll take you basically a lot of the stuff that I said in a little bit more detail. So if you want to learn about key presses, how to handle those, just beware this is in C++. So I'm not a fan of C++, but just know there are some differences from what I've been talking about today, which is just in regular C. But like texture loading, a lot of the commands are the same there. And I did use some of this as a reference for this talk today. But yeah, it gets into detail like alpha blending, which I didn't even touch today. Scrolling, text input, file. Yeah, file reading and writing. So yeah, this is probably a little bit different. I guess SDL has its own file reader. That's interesting. Let's see here. A couple other sites, tutorial points, SDL tutorials, SDL. There is a nice video, I think it's this one right here, by one of the people who have worked on SDL. let's see. Yeah, this guy right here. What's his name? I forgot his name already. Yeah, I just had his page up. I think he's Iculus. But yeah, he knows a lot about it. If you just want an overview of
what it will do is use
SDL, I definitely recommend watching this. It's from Steam Dev Days. It's at a little bit higher level than the talk that I've done today, and just basically tells you how to get started, what it can do, and things like that. Ryan Nicholas Gordon, that's his name. And all about linked list. If you want to learn more about linked list, you can go here and plop that in. And it'll tell you about the data structure, how it's allocated, a lot more detail of what I went in today. So this is a really good reference right here. Okay, so that's it for SDL. Close this. Stop sharing. So Jacob, are you still with us? Yeah, Jacob may have dropped off.
I'm still here.
Oh, okay. Well, yeah, thanks for joining this month.
You're welcome. Sorry I didn't have anything to show.
Yeah, I know this is probably not that exciting of a talk, and I appreciate you joining, though. And yeah, I hope you and your father have a great Christmas and New Year. And yeah, I guess we'll plan on doing another podcast in January. I don't have a talk planned or anything like that. As always, let's see here, share screen, share. Everybody go out and check out Knoxville Game Design website. You can sign up for the meeting list right here. I started putting the link to the Discord in the mail as well, so if you need a link to that. There's an issue with the forums right now. I tried logging in, and I don't think the login's working anymore, so I may just pull the forums down, and I don't think very many people used it anyway. I've got the directory and the archives of all our games and events and things like that are coming up on that. Yes, stop screen sharing. It's going to wrap it up for December 2019. Appreciate everyone out there listening and watching.